Good afternoon, everyone. Hope all is well and everything is all right. So, right now, we're just waiting for everybody to get in, and then we will go ahead and get started. Looks like everybody who's trying to get in is in. All right. So, like I said, good afternoon. Hope everybody's doing all right. Hope you all had a great holiday because I haven't seen y'all. Didn't see you on Monday, so and we're about to go into the weekend. So it's a good week, right? So we are going to get into chapter 3 today, starting with 3:1. Any general questions before we go ahead and get started? Everybody good? That's straight. See you, my only person, my only one head nod. Appreciate you.
I have a quick question. I'm
Mm-hmm.
sorry.
Are you fine?
Um, the definitions, were they due by yesterday night or tonight, or were they due by the weekend?
It was supposed to be by tonight. That was the date I put out.
Okay,
If you're having issues getting it in by tonight, if you can get it in before the weekend, I still can work with that. That's fine.
okay. Sorry, I'm still like learning everything from TCC. This is like my first class. So, as for like homework 1 and 2, is that also due today?
No. Now,
Okay.
and so I will say this too when you said learn TCC. Now, how I roll and how another instructor roll may be a little different. So we don't have like a strict way that everybody does their class. So we do have a little bit of academic freedom. So now the way I'm doing this class, and I don't even do all of my classes the same. So I do statistics different than I do pre-calc and so on. So the way I do my statistics classes and their due dates is that I have a hard due date at the end of the session, which is August 8th. That's the last day we have to submit any type of work before I have to get grades in. So I gave you as much leeway as I can. So what that does is it gives you room for life to happen, and you don't have to ask me for any type of extension or anything like that. You can just go ahead and get caught up. So you have until August 8th for everything that I put in my math lab. Only thing about that is that what you don't want to do is wait until August 1st to start working on work. You know what I mean? You want to progressively be doing your work as we go throughout the course, as we go throughout the lectures. Like today, we're going to get started with chapter 3. So at some point, you want to get out of chapter 2 so you can start focusing on chapter 3. So that's how you want to gauge it.
Okay, thank you so much. Yeah, I came from ODU, and so everybody uses Blackboard, and so I'm still
Hmm.
trying to learn how to use Canvas and stuff like that. So,
Yeah, yeah. Trust me, I get it. I get it. Yeah. So if you have any questions, feel free to either shoot me an email or ask during class. It's not a big deal. You good.
thank you.
Hmm. Set my definitions through personal email instead of TCC email. Does that work, or should I resend it through TCC? Let me see. I haven't checked my email today, so I don't want to say your name wrong. Is that Snetzer? Snetzer? Okay, Snetzer. Okay, good. But yeah, I'll check my email. If you don't see a response from me by the end of the night, because I'll send you an email saying got it or received or something like that, then you know I didn't get it. So give me till the end of the night. Maybe okay, tomorrow morning. If you don't see anything from me tomorrow morning, then you may have to resend it. But it should, yeah, not a problem. But it should have went through. It should have went through. All right, we still got people coming in. So good thing you guys had.
I sent in my definitions, chapter 1 and 2, through your through Canvas.
Hmm.
So I
When you,
went to like
yeah, when did you send it?
I sent it last last it was like last week
A whole last
on a
week?
weekday.
Wow, a whole last week. Let me see. I should have saw that one. Let me
Yeah.
see. Williams.
It was
It is under
yeah,
Williams, right? Okay.
yeah, Williams, chapter 1 and chapter 2
Okay. Triana.
definition.
Yeah, I sent you a response that said got it. Thanks.
Alrighty, perfect.
Okay. Now I see. Let me see. These are you're 1 and 2. Yeah. So now I don't know if I put yours in my math lab yet, but I did send an email responding to it. So make sure
Alright,
you check that. Make sure you did get a response from me so that communications are complete. You know what I mean?
of
But
course.
yep, yep.
I
Uh,
just sent I just sent my definitions probably an hour ago.
okay. Yeah, I haven't checked my emails yet today.
Okay.
So yeah, yeah. So give me tonight. I'll probably shoot you that response, let you know I got it. Yep. Let's see. Somebody else said good afternoon. I'm new. Add to your class. I'm trying to jump in and catch up. Okay. Mr. Green, check Canvas announcements. So any email that I've sent, you probably wouldn't have got those emails because you weren't logged into the class. But I have archived all of your emails, all of the class emails in Canvas announcements. So check out those. I think it was like first 4 emails. That pretty much sums up how we're gonna handle class, everything that's going on in class. Check those emails out, and if you have any questions, shoot me an email. Let me know you got some questions or something that was written there. But if you check out those first 4 emails, that should put you in a good place as far as where to go. You got some definitions that you need to knock out. Um, that is in Math Lab. Once you sign on to Math Lab, you'll see chapter 1, chapter 2 definitions. Since you're just getting in, so we got a little leeway on that. Of course, you get an extension. But yeah, check out those first 4 emails and then let me know if you have any questions on that.
Yes, sir. Thank you.
Yep, not a problem. Anybody else? Anybody else before we get rolling? Everybody good? All right. And back to you, Mr. Green. First 4 emails are introduction. I record all lectures, so that next email, I think it's the 5th one, maybe the 6th one. Different classes do different things. But I think on your 5th email is the link to each recording of last week. So you can check out those recordings as well to make sure you're caught up. So
Thank you, sir.
yep, not a problem. All right, so let's look at our first 4 lectures. I think we'll do 3132 today. I know we don't do 3-4. Okay, so let's get rolling. Okay, all right. So we're starting off with 3-1 today. Measures of central tendency. All right. First thing in 3-1 is your mean. In statistics, the mean is just another word for average. So the same way you will find your average or calculate your average is the same way you will find the mean. Add all the data values and divide by the number of data values. This over here in green, you don't necessarily have to copy that down. That was for another class with the book. They focus on that type of terminology. You really don't need that in the green. But we're looking at the black and the red. So add all your data values, divide by the number of data values. And then in the red is just a simple example of doing that. If our data set was 1, 2, 3, 4, 5, add up those numbers. We have 5 data values, so we divide by the number 5. So 15 divided by 5 is 3. That would be your average. All right, any questions on that? As a matter of fact, let me write myself a note. This is for 155. All right, anybody still copying this before I scroll up? All right, and always, if I scroll up on anything and somebody's still copying, either unmute, say, hey, I'm still copying, or type it in the chat. I'll see it in there as well. So either way, it's fine. Then I'll slow up or pause. Next term that we're dealing with is your median. You can think about your middle value. That's what your median will be for you. The first thing you want to do, and notice I put here, don't forget, because a lot of people do forget that first step, is you want to list your data values from least to greatest. You have to do that first. Then number 2, if the number of data values is odd, you're going to just take the middle value. If you have an odd number of data values, then you will have a middle value. But then in your third step, if the number of data values is even, you take the mean of the 2 middle values. Because if it's an even number of data values, you don't have a legit middle value. So you take the 2 middle values that you have, add them together, divide by 2. And that will be your median. All right, give you guys a chance to write that before we do a quick example. All right, scrolling up. All right, so we have two different data sets. Data set one is 1, 2, 3, 4, 5. So we have 5 numbers here. And so we have an odd number of data values. So since we have an odd number of data values, that means we do have a middle number. And that middle number is going to be 3, 4. So that's why the median is just 3. All right. In the second data set, we have 1, 2, 3, 4, 5, 6. So this time we have an even number of data values. That means there's not a legit middle number. So what we'll do is we'll take the two middle values, 3 and 4, add them together and divide by 2. And that's what we did here. Oh, left my eraser on. There we go. So that's what we did right here. 3 plus 4 divided by 2. 7 divided by 2 is 3.5. And notice that 3.5 goes right here in the middle, separating your data set, splitting your data set in half. And that's what your median will do, split your data set in half. And that's what the green right here says. The median separates your data set into halves. Any questions? Oh, okay. All right, can I scroll up? Everybody good? All right, next one, your mode. You can think about most or most frequent when it comes to your mode. That's the data value that appears the most frequently. It is possible to not have a mode. It is possible to have more than one mode. Two modes. Two modes is considered bimodal. More than two modes, multimodal. All right, any questions on that? All right, so here we have a data set, once again, a random data set that, we're looking at 1, 2, 7, 8, 9, 6, 7, 5, 2, 9, 7, 6, 5, 1, 3, 4, 7. So 7 would be the mode because 7 appears 4 times, which is the most out of all of them, all of the repeated values. All right, any questions on the mode? All right, here we have a summary of data. It's said to be resistant if outliers, in other words, very extreme values. We should have come across outliers in our definitions. Outliers are very extreme values in comparison to your data set. So in other words, you're talking about very, very large or very, very small data values. Those are considered outliers. So they're resistant if outliers to the data set do not affect it. So that's the term in this passage, which is resistant. A summary of data is said to be resistant if outliers do not affect it. All right, show you what that means in a second. All right, first data set. We have 1, 2, 3, 4, 5. The mean, which is the average, we already calculated the average for that to be 3. And also the median of this data set is 3. Okay. Now, if I were to change that data set and make 500, now 500 would be considered an outlier in comparison to the data set. So if I find the mean, if I add 1, 2, 3, 4, 500, that's 510 divided by 5, that's 102. But if you look at the median will still be 3. So it wasn't affected by the outlier being, or it wasn't affected by 5 being changed to 500. So it's not affected by that existence of an outlier. So this means that the median is resistant to outliers. The outlier, the presence of the outlier didn't affect the median. But you notice it very much so affected the mean. So the median is resistant to outliers. All right, any questions? All right, any questions before we go to the next thing? Everybody good? All right, so that's it for 3.1. 3.2 is measures of dispersion. So dispersion is the degree to which the data is spread out. All right, so the first term that helps us to measure dispersion is your range. And all that is the largest data value minus the smallest data value. So in our data set here, 1 through 5, I would take 5 minus 1, and that will be 4. So using your range is, you would use your range in order to help you compare the spread of data sets. You have different data sets or different groups of data that you're trying to compare. Any problem with the range? All right. So next is your standard deviation and then your variance. So your standard deviation measures how far data value is from the mean. Your variance is the standard deviation squared, and just another way to measure the spread of your data. All right. So now, this book doesn't hold you accountable for the process of actually calculating the standard deviation or the variance. There is a formula to it. But the book doesn't hold you accountable for knowing the formula or knowing how to use the formula. So I won't make that a priority as well. I mean, if you were math majors, then I would do that. But the process can be very long and tedious, especially once you go over 20 data values. It's one of those things where if you mess up one value, it messes up everything moving forward, and then everything will be off. And so like I said, if you guys were math majors, then I would be holding you guys to the process because, you know, that's your thing. That's your flow. You're supposed to be math oriented, process oriented. But since you're not, what I am holding you responsible for is finding an app, calculator, website, something of that nature that will help you calculate the standard deviation and the variance. All right, an example of that is easycalculation.com. And I'm not asking you to pay for anything else. This is completely free. Now, if you choose to pay for an app that does it, then that's on you. But there's a whole bunch of free stuff out there, and I'm about to show you easycalculation.com in a second. That's one I use, just an easy go-to. But yeah, if you choose to use money, then that's fine. But I'm not requiring you to pay for anything else other than access to my math lab.
I'm sorry. I just wanted to be sure so we won't have to, so we're not going over the formula for it.
No.
Okay.
Mm-hmm. But I will show you what I mean by, because that's the formula right there down there in red. But like I said, it can be a little bit of a process once you go over 20 data values. But once again, the book isn't holding you responsible for it, so I'm not going to worry about it. But what I will do is show you. Let's go Google. How we can do this. So going to the notes, that's just an easy way that you can sit here, an easy data set that you can test whatever app or website you decide to use, plug those values in, hit enter. If you're doing more than plugging values in and hitting enter in order to get your standard deviation or your variance, then to me, you're doing too much, because there's a lot of free stuff out there that you don't have to do anything. If you have to store values in one place, pull it from another, then transfer, if you have to do a whole bunch of a process, then to me, you're doing too much because we have a lot of stuff out here at our disposal. Oh, hit the wrong button. Where'd it go? All right, there we go. So if you just Google standard deviation calculator, I like to do easy calculation, but you don't necessarily have to. But if you do standard deviation calculator, easy calculation, then there you go right there. And make sure you pay attention to the directions that your website, app, or whatever tells you. This tells us just to enter all numbers separated by a comma. Some use semicolons, some use spaces, everybody do something different. Just depends on what's going on. So I'm doing 62, 88, 77, 68. And there you go. So when you get into your terms, you see that, you have symbols for your sample and symbols for your population. And population sample is talked about in your definitions. And sample is exactly what it sounds like, just like when you go to the grocery store somewhere or the mall and they're giving out samples. I don't even know if they do that anymore considering COVID, right? But they give out samples of a little piece of, the actual dish. It's the same type of thought process. Your population is the whole. Let's say all the TCC student body is the population. This class is a sample of that population. So to find the standard deviation for the sample versus the standard deviation for the population, the formula is a little different. So that's why you see the numbers that are different here. If you only have 4 values like I just did, then that more than likely would be your sample versus a population. Population is going to be a large number of data values. But here's our standard deviation, and then here's our variance. And then here, if you were looking at if that was considered your population, then they calculate that for you as well. All right, questions on what we did here? Questions on what is expected of you when it comes to calculating your standard deviation and your variance?
So I have the TI-83, and I just did what this video just told me to do. What are the little symbols? Like the backwards E and the X, and then the X with the line is average, right?
Let me make sure. I'm gonna write them down and make sure. Oh, matter of fact, this is where we are. That's the next thing we want to get to.
Okay.
So, do you see the symbols you're talking about, right?
Yep.
I see the X with the bar. Okay, and this. Okay, so we're about to talk about it in a second. All right. So I just want to make sure we were good. So is everybody good with standard deviation and variance before we get to our notation? Is everybody good? All right. So, like your classmate just gave us an awesome segue into notation. So, depending on your population versus your sample, you will have different notation for each. And when you see the notation without them saying it, and you got to remember this is math. When it comes to math, they want to write the least amount of words possible. And if they have a symbol to represent a whole sentence, that's what they want to do. You know what I mean? So um, the symbols here will dictate or let you know that you're dealing with a population versus dealing with a sample. So your data value is always going to be X, no matter whether you're dealing with population or sample. That's never going to change. Your data value the data value that's in question or the data value that you're trying to convert will always be X. Then we have Greek letter mu. That's your population average. And then here, this symbol right here is sigma, but it's lowercase sigma. And that's going to be your population standard deviation. So the reason why I mentioned it's lowercase, because capital sigma, which I think a lot of you have seen, whether it be from the fraternities or we see that symbol a lot just out there, right? Capital sigma represents summation, so that means add all of the data, add all of your values. So that just means addition of all the values that you're referring to. So that's what that's what this symbol Greek letter is. And then here, sigma squared, lowercase sigma squared is your variance. Capital N is your population size. So if you see somebody say N is equal to 1,000, that means the population size is 1,000. All right, then looking at sample, like she mentioned, X bar. So any variable with that line over it is that letter bar. So just like if I had Y with the line over it, that would be Y bar. But that's going to be our sample average, our sample mean. Regular S, I guess they ran out of Greek stuff to do, I don't know. But the regular S is going to be our sample standard deviation. And then regular S squared, those are lowercase s's. Regular S squared is your sample variance. And then lowercase n is your sample size. So capital N was your population size. Lowercase n is your sample size. All right, any questions? All right. Are you still copying before we scroll up? Make sure we're all right. Oh, gotta go to the other page. All right. So next part of 3.2 is the empirical rule. Let me erase this right here, get it out your way. I'll put it back later. So approximately 68% of your data is within one standard deviation of the mean. Approximately 95% of the data is within two standard deviations of your mean. And then 99.7% of your data is within three standard deviations of your mean. So I'll give you a little diagram on what that means in a second, but I'm gonna give you a chance to write that out. We're just talking about going out one standard deviation in both directions, two standard deviations in both directions, and then three standard deviations in both directions. Miss Amanda, I'm curious, is that Andrick or Andrich?
If you say it the right way, it's the second way. My husband's
Oh,
from Serbia, so
right, okay. So that's why I saw it. I was like, I don't think, you know what I mean?
nobody
Okay.
says it that way. So.
Oh, that's cool. That's cool. right, are we good to go to scroll up? Anybody still copying?
I'm still copying.
Okay, not a problem. All right, not a problem at all. All right, we good in the chat. Anybody else? Can I scroll up at least past the 95%? There we go. All right. So there's a diagram that emphasizes those three sentences right there. This is based on normal distribution. Remember, we talked about normal distribution. It's symmetric about the mean. So that means you have your mean in the middle. 50% of your data will be on the right of it. 50% of your data will be on the left of it. So these percentages do not change. All right. So that is your empirical rule, that those percentages do not change. These percentages right here, 99.7, 95, 68%, they do not change as well. That is your empirical rule, those percentages. Now these numbers down here will change according to the information, whatever your mean is, whatever your standard deviation is, those data down bottom will change. But once again, these data values, these percentages will not change. So that's 34, 13.5, 2.35, and 0.15 on both sides of the mean. All right, so is everybody good before we put this to work? Still copying? All right. So give you a chance to write this down. We have the mean IQ score of students enrolled at University A is 100, and the standard deviation, just wrote SD for standard deviation, is 16.1. Determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. Determine the percentage of students who have scores between 67.8 and 132.2. And then determine the percentage of students who have scores above 132.2. So like I said, I'll give you a chance to write this down before we get rolling.
Can you read the first part again?
Yep, the mean IQ score of students enrolled at University A is 100, and the standard deviation, all I wrote was SD for standard deviation, says, and the standard deviation is 16.1. All right, and DET is determine. Determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. All right, can we scroll up? Are we good? About straight. All right, so once again, go ahead and run through it as far as word wise. The mean IQ score of students enrolled at University A is 100 and the standard deviation is 16.1. Determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. That's the first question. Now, when it comes to question A, we really don't have to do any calculation. We can just lean on the empirical rule. So it says determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. But if you go back, you know, approximately 99% of the data is within 3 standard deviations of the mean. So really, we don't have to do any work to find A. You know, according to the empirical rule, 99.7% of the data is within 3 standard deviations of the mean. So that's all they're asking for in A. So questions on that? Make sure we're good before we go to actually putting some numbers on this and working it out. All right. So once again, it says according to the empirical rule. So if you're just leaning on the empirical rule, you just go back to your statements and say, look at what a percentage that they said about 3 standard deviations. So now let's look at filling out this empirical rule chart. When you go to the chart, notice you have your mean in the middle. Then you have 3 data values to the right, 3 data values to the left of it. The way we get the 3 data values to the right is that we add a standard deviation 3 times. The way you get not standard deviation, but the way you get the 3 data values to the left of your mean, you subtract the standard deviation 3 times. And that's what we're going to do. So we already know, according to the according to the information that was given, our mean is 100, standard deviation is 16.1. And all I was emphasizing here is just the difference in the symbolism. I decided to use population symbols, but if you wanted to use sample symbols, then you would have used X bar and S, you know, for those respectively. All right. So now when you're talking about the right side of your data, all you would be doing is, like I said, is adding a standard deviation 3 different times. So you take 100, add 16.1, then add 16.1 again for the second value, add 16.1 again for the third value. And that would be these 3 values right here, 116.1, 132.2, 148.3. So that would be the right side of your mean, you know, the 3 values on the right side of your mean. And then to find the left side, you're going to subtract 16.1 from 100 3 times. So do that 3 different times, you get 83.9, then 67.8, and then 51.7. right, questions. Before we go any further, make sure we're okay. All right, so now to fill out our distribution chart, notice we have 100 in the middle. That was our mean. To the right of the mean are those three values, 16.1 added 3 different times. To the left are the values of us subtracting 16.1 3 different times. Also take note that, remember I mentioned those percentages do not change. All right, any questions on anything so far? So let's go back to what B asked us. Determine the percentage of students who have scores between 67.8 and 132.2. So what you would do is that you would find 67.8 and 132.2 and add the percentages that are between those two numbers. That's what they ask you for, the values that are between, or the percentages between those two numbers. So we add 13.5, 34, 34, and 13.5, and you see that we have 95%. All right. And so this empirical rule, you can play with it, a lot of different ways. If you wanted to ask, what's the percentage of students that we anticipate scoring between 100 and 116.1, then that would just be 34%, because that's the only percentage between those two numbers. Or if you wanted to do 83.9 and 51.7, then you would add these two percentages together. And so it's just different ways that you could play around with, these numbers and percentages to see what you would anticipate according to the empirical rule, what type of percentage you would anticipate, occurring. There you go. All right. And then C, it says determine the percentage of students who have scores above 132.2. So always got to pay attention to the keywords. So we have 132.2, but we want to know above. So we're talking about greater than 132.2. So we will add these two percentages together. So that's 235 or 2.35 plus 0.15, and that's 2.5%. So you anticipate 2.5% of students to have an IQ score higher than or above 132.2. All right, questions. Anything, anybody?
I have a question, Professor. How many sections are we going over today?
Oh, we about to do 5, 6, 7 of them. I mean, you ready for it, right?
Yeah, I'm ready. I just wanted to know.
No, actually, I'm probably going to pause right here because I don't know if y'all remember, I said that I'm playing this juggling game with you guys as far as how much content to throw at you at once, and then when do I pull back. So I'm trying to create this happy medium of doing that. So we did 2 sections, but you see we still have time. But I'm going to pause right here because you still have chapter 1, chapter 2 work to do. And if I keep going, we'll be done with chapter 3. Because chapter 3 is it's not a heavy content. So I'm not gonna do that. We only have 2 more sections to cover, which, like I said, we could complete them with the time that's allotted, because I believe this class goes from 1 to 3, if I'm not mistaken. So we do have time to finish those, but I don't want to put us in a position of we already done, we chapter 1, chapter 2 is already in the past, and then put chapter 3 in the past, within one day. So we're gonna pause right here. Next class though, we will, do 3 and 4, which will, 3, 4, and 3, 5, which will put us out of chapter 3. And then we'll be looking to go into chapter 4, sometime next week as well. So that's why I was trying to warn you guys, this is the summer. So you do want to make sure you're on top of your work and you're knocking this stuff out. And yeah, we'll go from there. Hopefully you're okay with that, Miss, is it Peachon?
Peace, Sean.
Peachon,
Yep.
okay. Okay.
Sounds good to me, Professor.
Okay, I just want to make sure. Now I want to make sure everybody happy. I don't want to shortchange nobody. Any questions or concerns before we close out today? Everybody's good. Everybody's straight.
I have a question.
Yep.
When does assignment 1 have to be in? Because I know it said assignment 1, assignment 2, assignment 3. When do those have to be in?
I'm not sure if I'm even going to do those. I have those set up during the 16-week course. It's easy to do different things like that because we have time, we have room. I have a little bit of leeway when I can fall back and say, okay, we don't have to do anything today, but do these problems and see if this, that type of stuff.
Yeah.
When you have a 10-week course, we kind of like bow, 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 bow. You know what I mean? So I probably won't do them at all. So don't even worry about them. If I mention them, then we'll go there. But I probably won't even mess with them.
Alrighty, I just wanted to make sure.
Yep, not a problem. Not a problem at all. All right. Anything else? Anybody else? Everybody good? Straight?
So the assignment, the homework on Math Lab for chapters 1 and 2, those should be completed by now, or?
Yeah, you want to go ahead and knock those out as soon as possible. There's not a penalty if you haven't done them yet, or even if you don't get them before the weekend is out, it's not a penalty. But you see that we're progressing throughout the course, and you don't want to keep having stuff getting thrown on top of you, and you haven't completed the old stuff yet. So that's the mentality you want to have, is that as we progress throughout the course, you want to be progressing throughout your homework and getting as close, keeping as close to me as possible with the lectures.
Okay. Thank you.
Yep, not a problem. And just to reemphasize, I see somebody said something in the chat. I'll check that out in a second. Just to reemphasize what your previous classmate had mentioned, the assignments that she's referring to are little tabs in my Math Lab that says assignment 1, assignment 2, and assignment 3. She's not talking about what he just mentioned, which is just your Math Lab homework. So you're supposed to be doing your Math Lab homework. Assignments are just something separate that that you guys do not have to do. What days will tests be on? Because there are days I work 12. Well, let's see. I don't know, but you will have a heads up. So if there's a conflict with that in testing days, then you just have to get with me. Shoot me that email, and we'll talk about what we can do if it conflicts with something that you got going on like that. Yep, not a problem. Most definitely got to work with people in the hospital for sure. We appreciate your service. Anything else? Anybody else? Is everybody good? Everybody straight? All right. So.
I have a question.
Oh, yeah. What you got?
For chapter 3 definitions, did we just get them out the book? Because I don't see chapter
don't
3
worry about them. Don't worry about them.
Oh.
Yeah. So it was just chapter 1, chapter 2. And we probably will do chapter 10. But
Okay.
other ones we have enough work to do wherein our work will emphasize the definition part.
Gotcha.
All right. Let's see, anything else? Yes, and you'll email me the definitions. Yep. Email me definition. You can take a picture with your phone. You can scan it on the computer, whichever way works best for you. As long as you shoot me that email with a copy of it that I can, check out, or you can just type it and then shoot it through Word. You'd be good to go. Yep, not a problem. Anything else? Anybody else? Anybody have any questions? Make sure you're good. And if you think of something after I close out, feel free to shoot me that email. I answer your question through that as well. Everybody good? Everybody straight? All right. So you guys have a great weekend. Be safe. I will see you on next class. That will be Monday. And we'll get back into chapter 3. Guys, take care.
Thank you. Have a good weekend.
Thank you, Professor. Have a good week.
Thanks. Do the same.
Thank you.
Thank you. Have a good one.